Before you graph the sine and cosine waves, you should know your unit circle, or you would have a unit circle chart. We're going to graph these by using the quadrantals. That means our 90-degree angles. For example, this is 90, 180, 270, and then 360. And I'm going to graph these between negative 2 pi and 2 pi. This is the table that goes with sine, and I suggest you copy it down. It's hard to keep copying it down on these slides I use. So copy it down, and this is the cosine wave. We're going to graph these, and they're just the parent functions, and we're also going to graph their reflections. Okay, the first one we're going to graph is the sine wave. So we're going to call this the sine wave. You need to know your quadrantals, and basically I'm just going to graph between 0 and 2 pi using the table, and then I'm going to infer the negative part from the first part I got. So what I'm going to do is 0 goes with 0, pi over 2 goes to 1, whoops, back to 0, 3 pi over 2 goes to negative 1, and 2 pi goes back to 0. Okay, I'm going to continue this on as a continuous wave. I'm going to go to negative 1, back up here to 1. And I'm not being exact here, I'm just sketching it, even though it's a coordinate grid. Alright, so I'm going to make it, it looks pointy here, but I'm going to make it curvy. Alright, and then just go down, curve up, and back. That's the sine wave. It's an odd function because it's symmetric about the origin. Okay. The next one's a cosine wave, and you should have had copied down the table if you don't have one in front of you, and it gets graphed this way. I call these dots, they're really points, but I call them dots. So do you see how I made a V here? And then I'm just going to curve it. Make it curvy, not pointy. Your teacher will get mad if you make it pointy. And I'm going to continue on. I'm going to go to negative 1, back up to 1. And again, you see that V shape, but make it curvy. Okay, this is your Y. This is your X. This is a cosine wave. It's an even function. It's a symmetric. Oops, sorry. It's symmetric about the y-axis. That means I can fold it on the y and it would match up. Okay. Now we're going to do the inverse, or not the inverse, the negative sine of x and the negative cosine of x. These are called reflections. Basically, all I did is take my original table here and negate my y part. So I just negated the ones, basically. Same thing with the cosine. I took my original table and then I negated the ones. And when you draw, we're going to draw a negative sine first. Negative sine of theta or x. And this time, instead of it, we're still starting at 0. But instead of going up to 1, we're going down to negative 1. And then just draw your characteristic points. So it just goes like this. It's reflecting across the x-axis. And then we're going to continue on, go up, go back down. All right. And that would be your y equals negative sine of x. And for cosine, we're going to put the range in here. Again, the range on all of these is between, we're calling it y, so it's in between -1 and 1, and it can equal it. So instead of starting at 1, we're starting at -1. And make your V shape. So basically you should have 5 dots. So I have my V shape, but when I draw it, and I know it's going to go up, so I'm going to make a V shape here as well. Okay, and when you draw it, just make it curvy, don't make it pointy. And that's the reflection about the x-axis. So this is y equals cosine of x, or theta, calling it x. So that's x, and this is your y. Okay, and I'm going to just do a little summary here. A lot of times we call these characteristic curves, but when you're drawing sine and cosine, just remember to do something like this. So you can do it really fast, but sine starts at the origin, so just draw dot, 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 dot. You could even label it later. There's your cosine wave. So that's, not cosine, that's sine. Now for cosine, we start at 1 and just make a V shape. And there's your cosine wave. These are between 0 and 2 pi. Okay, so again, dot, 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 and this is your line here. And for cosine, dot, 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 and there's your sine. If you can get used to drawing it like that and then filling in the radians at these key quadrantal points, it'll make your graphing a lot easier. The next video we're going to talk about is the amplitude and graphing the parent functions with their with amplitude changes.